Hello student, today we will see the diffraction of light. Our topic is diffraction of light. So let us see what is the diffraction of light. First we will see the definition and then I'll explain it in a proper way so that you can understand better. According to the definition, the phenomena of bending of light around the corners of small obstacles or the apertures and its consequent spreading into the region of geometrical shadow is called diffraction of light. This is the definition. In that, if we just focus on the main point, that the bending of the light around the corners, and due to that bending of light around the corners of the obstacle or the aperture, due to that it enters into the shadow region. This phenomena is called the diffraction of light. Let us see with the examples. Means, suppose this is the light source. There is a light source and it is spreading in all the direction, and suppose I have put a slit in front of that, and from this slit the light is entering. So basically if the screen is there, so we will think that the light will come through this slit and we will get here only the bright portion, means the light will fall on this portion only, and this is the bright portion, and rest the entire this one is the dark, and this one portion will remain the dark. This is the dark position. You will think like that, because light travels in a straight line, so it should go through the slit and it should impact on this place only. You will get the bright patch over here, and rest the upper portion and the lower portion should be dark. But in a true sense it is not happening. Actually what is happening, when light enters through this slit, then what is happening, it goes a little bit bending over here and it goes in the darker region also, in both the direction, in both the side. This is the darker portion where it enters, or it bends towards this darker portion, and you will get a little bit blurred patch of the brightness. So overall from this portion to, from here to here, you will get a bright patch. This is the bright patch. So this phenomena is known as the diffraction, means entering of the light, entering in the darker portion through the edges or the corner of the obstacle, whatever the obstacle is there. So this is this phenomena of bending of light through the corners or edges of the obstacle into the darker portion of the shadow. This is known as the diffraction of light. Means like this way, or in the other way you can understand. Suppose the light source is here, one light source is here. This is the first example, and another example. If suppose I have put an obstacle over here like this, so light will go straight. This is the screen, so light will go straight, and you will get like this. But what is happening, it will bend a little bit this direction also. it will bend little bit in this direction also. So this portion will also be, there will be a bright patch, this, so that this one and entire this is the bright patch. So this is the phenomena of diffraction, because light entering through this side also, where the actually we are thinking this portion should be darker, this portion should be dark, but in this darker region also the light is entering. So this phenomena is the diffraction. If you take the aperture, means a small hole, suppose you have taken a small hole in front of a source, this is the light source S, and in front of that you have placed a aperture or small aperture. So light, as we know that light travels in a straight line, so it should go pass through it, and in front of that there should be the similar hole or the bright patch over there. But in fact this is not the smaller, it is a little bit broader than this. Means what is happening, light goes and it bends through the edges of this one, it bends through the edges of this one, and it enters into the darker portion also. So you'll get a bright patch which is more than, means it is bigger than the size of the aperture. So this phenomena, and then you will get the little bit darker, means not exact very dark, but slightly it will, means diminish, and then gradually it will, you will get a darker portion. And so but then you are not getting exactly after the bright, you are not getting the sorry, dark portion region or the bright region like that, because there are the fringes, because after the dark then again a bright fringe, then again a darker fringe like this, and then again the another bright fringe, then again the darker fringe, like this way it will go on. One bright, one dark, one bright, one dark, one bright, one dark. Means if the source is here, if the source is here and it passes through a slit, it passes through a slit, so it should go straight, but it is not going straight, है ना? What is happening here, this is the darker portion but a little bit bending over there, so the light bends in the darker region this way, in that darker portion. So in this portion, so overall from here to here you will get a bright patch, means this is the bright region, or the, which is called the central maxima portion. This is the central maxima portion, which is called the brighter one, and after that you will get a dark portion like this. Then this is the dark portion, dark patch both the side, and after that darker one, then again you will get a bright portion, bright patch of fringe both the side like this. Then again you will get a dark patch on both the side, and then again a bright patch, and gradually you will see the brightness, the width of the brightness is decreasing. That is why slowly it becomes faded, and then the darker portion increases. So then again a dark patch like this. So this way we are getting the fringes over that. Means first you will get, overall you can see, first you will get a bright spot like this, then the darker portion like this, then again the bright portion, bright fringe, this. Not the very sharp edges, you will not get the very sharp edges of all this, है ना? Then again the bright patch, darker patch, then again you will get a bright patch like this. Then again you will get a dark patch. So this way the fringes are generated, this way the fringes are generating, and this one is the central bright fringe, then first bright, then the second bright, and this is the first dark, then this is the second dark, like that, the third dark. This way you will get. So let us see. Now you understood how the diffraction is taking place through all these examples. Now we will discuss about the single slit experiment, through which we can see that we can understand better this diffraction and about the bright and the darker fringes. Okay. Now the student, we will see this diffraction of light at a single slit experiment. For that, suppose there is a source of light, and we had placed a slit over there in front of that light source, and from this slit the light is passing through this slit, and in front of that we have placed one screen. So what is happening? First you should know about the difference between the slit and the aperture. Slit means when you are just, suppose we had taken this sheet and we had made a cut, a very thin cut over there, then this is called the slit. Means through this the light can pass through it, and through this plain vertical cut over there, this is called the slit. And aperture means when we make a hole, when we make a hole, a small hole, and through that the light passing out like this way, then it is the aperture. Clear? That is the difference. The slit is a vertical straight cut. So we had placed a slit in front of the light source, and light is passing through this. So as the Eisen said that it produces a wavelet, and on that each particle of this wavelet, means it goes like that. As you know, the wavefront and wavelet, the light source producing the wavefronts like this, and on these wavefronts each particle of that is the wavelets, and these wavelets are producing the secondary wavelets, and both are traveling with the same speed and perpendicular to the front. So accordingly, on this slit, each particle of this wavelet is a secondary wavelet, and they will produce the another wavelets, and they will propagate with the same speed and all. So as you know, the first wave, which is coming out from this M that reaches over here at the O, and from N both are traveling the same distance, so here no path difference, so delta x is equals to 0. And as you know, when delta x is equals to path difference is 0, so you will get the bright fringe. Like that, from the other sources, other point also, these will come and reach over there, and they all the secondary wavelets or these wavelets from these waves are coming and reaches over here. The path difference is 0. As you know, the path difference is 0, so then the phase difference will also be 0, because phi equals to 2 pi by lambda into delta x. If x is 0, that means the phi is also 0, means delta phi is also 0, means no path, no phase difference. And when no phase difference, so there is always a bright fringe, that you will know, you know it, that is bright fringe. So here that entire is the bright, you will get a bright patch over there. Similarly, all they will interact, and you will get a bright fringe over there, and then due to the diffraction, brightness will, you will get entire this portion, because it is spreading, it is light is bending through the corners, and the entire portion is, you will get the bright patch. And after that, at after certain distance, then you will get the dark, then again bright, then dark, then bright, as I have shown over here. So from that only, suppose to just discuss all this thing in a proper way, we are generalizing over here. So first we are considering a point P, and let us see what is happening over here, how the waves are reaching over there. Is there any path difference or phase difference? Which type of the condition will develop over here, whether the bright fringe or the dark fringe? Let us generalize it. So we are considering a point P at which the waves are reaching from the M and N both. So let us see how much the path difference between, because we can see the distance of MP and NP, that is the difference. So obviously the path difference should be there. So how much path difference is there? So the path difference means path difference, suppose this path difference is lambda. Here we have supposed that the path difference of PM and NP is the lambda. Then we can write, first we write this NP, it is the more, so NP minus MP, that is equals to lambda. We had supposed this is the lambda, so just we should draw a perpendicular from here. Suppose we had drawn this perpendicular from here. Now this and this both is the, suppose this is the point we have taken K, it means MP and NK is now the same, equal, where MP and KP equal, and this time it is equal. So NK is the extra length, this is the difference, that is the path difference, NK is the path difference, and that we suppose that it is the by lambda. Clear? So if the angle from this point, this is the midpoint between this M and N, so from, suppose we had joined a line from this point to the P, and suppose this angle is theta, this angle is theta. So if this angle is theta, so this angle should also be theta, means between these two lines, this angle is also theta. If this is theta, because this line and this line makes an angle theta. Over this line, this is the perpendicular, and this line is the perpendicular on this also, you can say. So if these two making angle theta, so between these two it will also be theta. So accordingly we can say that nk, this mp minus mp, that I can write over here nk, and nk equals to lambda. So this is, you can write a sine theta is equals to lambda. Clear? So from here we can take sine theta equals to lambda upon a. If this is the position of the first dark fringe, because the part difference is lambda, so it is the first dark fringe you will get over here. Till here it is the absolutely bright, this side it is the absolutely bright. This is the central fringe you will get here in between this region, and after that lambda part difference here, the point where you will get a first dark. So sine theta, this is the position of that. If the angle is theta is very small, if theta is very small, then sine theta, that will be very near to the theta, or similarly tan theta will be very near to the theta. So I can write this theta is equals to lambda upon a, that we can take. And if suppose this OP distance is the y, and width for y, then tan theta is equals to, this upon this, it means it will be y upon d, or that we can say theta is equals to y upon d, equation number 2. So accordingly we can write y upon d is equals to lambda upon a, that we can write. So the y is equals to, it becomes lambda d upon a. Is it clear? So this is the position or the width of the first point P that we have taken, that y is equals to lambda d upon a. This is the first width, means from this to this, O to P, OP, that is the y only. Now let us consider few things, and we think about that. Key at this point, which type of the condition will arise, whether it is the dark or the bright. So this is the point where you will get the first dark. Why? The reason I am giving you, because at this point the path difference is a lambda, a complete width, that is the lambda. If suppose we are considering this is the midpoint, it means if it is the midpoint, for full slit the path difference is lambda, that you have seen. So for the midpoint it would be the path difference between these two will be just lambda by 2, half, है ना. it means it will be lambda by 2. Suppose we have taken this another point PQ, suppose we have taken an L. Suppose we taking this point L. This point L. It means if for Mn path difference is lambda, that therefore for the midpoint of Mn, which is L, path difference will be lambda by 2, means just half. If the path difference is lambda by 2, it means they will reach over there in the opposite phase. And if they are reaching over there in the opposite phase, so you will get the dark fringe, means the brightness will be 0, because both are in the opposite phase, so it will be 0. So similarly for these 2 points it was opposite phase. Similarly for the next point and here for the next point, they will again reach over there in the opposite phase. Then the next point and next point, they will reach over the opposite phase. I am showing you this in this way. In the big screen you see, suppose here it is the point slit, that is I am showing it is the M and this is the N, and this is the midpoint, and midpoint that I have written over L. So it is half of this, means A by 2, and this is A by 2. It is half of this slit. So if the path difference between M and L, it is over there, is lambda by, it is lambda. The path difference for this is the lambda, this. So for the path difference for this and this point will be how much? It will be, you draw the perpendicular over there like this way. So this length will be lambda by 2. It will be half of that, lambda by 2. So similarly for the other point in lambda by 2 means which wave is reaching coming from this M and another which one is from L, they are in the opposite phase over there. If they are in the opposite phase, the resultant will be 0. And when opposite phase, to you know that one is going this way, another is reaching over this way, the resultant is the 0. This yesterday I have shown it. So it means like that the other wavelets from here, they will also, respective wavelet, they will also reach in the opposite phase, means which comes from here and which comes from here, they will opposite phase, which comes from here and from this, they will opposite phase. Like that, all the other wavelets which are coming out from these other wavelets, they are reaching in the opposite phase, and resultant is the 0, means they are neutralizing each other. So till here you will get a brightness or the bright fringe over this side, and similarly on this side also. From this side also you will get a bright patch over there. From here to here, this is the bright patch, and this is called the central fringe. This is called the central maxima or central fringe, which is the brighter portion which you can see. It is the brighter portion which you can see in this figure, this zone. And after that, when the complete part difference is lambda, then from here you will get the first dark. This, and here also, from here only you will get the first dark. So this is the case where you will get the first dark. Okay. So now if we take the first, we have seen the position of the bright. The position of the bright is that theta is equals to lambda by sine theta. We got it till here. You are getting the bright a sine theta equals to lambda. It means this width from P to O, that is y, and y is coming lambda d upon a. So overall the brightness, you are getting the bright fringe over here, this and plus this side you are getting from this and this side, both the side of this line. So this is the y, and similarly the down, this is the y. So overall it becomes 2y. The width of the central maxima, that is the 2y. So if it is the 2y, so the width of the central maxima, therefore the width of the central maxima that will be equals to 2y, and this width will be overall, the width will be the central bright width of central bright, width of central bright fringe will be, that is 2 lambda d upon e. This comes over here. This comes over here. The total overall width of the central bright fringe is equals to 2y, as I have shown. This side is the y which I have taken over here, and similarly the down portion, downside is also there, means from this side also y, this y. Overall width of the central bright fringe is the 2y, so it will be the width of that central bright fringe is 2 lambda d upon e. Clear? After that you will get the dark fringes over there. So for the position of the dark fringe, therefore from here the dark fringe will start. So the position of first dark fringe, that will be it will be, from that you got the value theta is equals to lambda by a, that you got the theta till here, from here to here, that is the total position of the theta. It was the angle theta. So theta, for the first dark, for the first dark position, means d1, theta is equals to lambda by e. Similarly for the second dark, it will be 2 lambda by a, like that. For the third dark, 3 lambda by a. This will go on. As it will go on, so and the respective theta will also be like that. For the first lambda by a, for the second 2 lambda by a, and respectively we can get the y also. So when we will calculate the y, accordingly, means y is equals to, you know that this upon this, so clear. Till here it is clear. The first dark you will get at lambda by a, which we had got from here, and similarly the second dark we will get 2 lambda by a. That you can understand by this way. As I have shown here, alternately we will get central bright, then the first dark, then the bright, then the second dark, then the bright, then the third dark. Like this you can see, while you can understand by this way. Suppose I'm showing over here, then it will be better. Okay, this is the light source, and you are getting here one by one from here. This is the central bright fringe. This is portion is the central bright fringe. After that, you are getting the first dark over here, which is at a lambda by e position, which is at a lambda by e position. Then the second dark, you will get where, that just now you have seen the second dark position. You have seen you are getting at 2 lambda by e. First dark you are getting the lambda by a from here. You all seen it is getting by lambda by a, and the second you will get at 2 lambda by a. So this 2 lambda by a means here it is the 2 lambda by a. Then that third dark that you will get over here, that is the 3 lambda by a. It means between the two dark, one bright fringe will be there. This is the dark, this is the dark, this is the dark. So between the two dark, after the central fringe, the first dark, then one bright, then second dark. So between the first dark and the second dark, one bright fringe should be there. So it means in between that, here you will get the bright fringe, the first bright. So the position of this will be what? The position of this will be at 3 lambda by 2a. Between these two you add and divide by 2, so you will get the center point. That is the 3 lambda by 2a. Similarly over here you will get the second bright, and this will be 5 lambda by 2a. So we are getting alternately dark, then bright, then dark, then bright, then dark, then bright. This entire here it is the central bright, and after central bright, first dark you are getting at lambda by a. Then first bright you are getting in between these two, first dark and the second dark, that is the 3 lambda by a. So it means the position of the first bright means you want to calculate it. So then the position for the bright fringe, you can write a formula that a sin theta is equals to 2n plus 1 and then lambda by 2. That it means you are getting theta is equals to 2n plus 1 lambda by you will get lambda by 2e. This is the position for the bright fringes. and where n you will put from n value you can put for the bright. First bright you will get n is equals to 1, then 2, then 3, and so on. 1, 2, 3, and so on. So first you will put 1 over here. 2 ones are 2 plus 1. So 3 by 2 lambda upon a for the first bright. For the second bright, when you will put 2, then 2 2s are 4 plus 1, 5 by 2 lambda by a. This way you will get the second bright. So this is the position for the bright fringe. In your syllabus only about the central maxima only, not for the other cases. This year it is only for the central diffraction and its central maxima. I'm just telling you in addition of that. And the position, if you want, the position will be y is equals to, for the first bright it will be 2n plus 1, and that the lambda d upon 2a. This is the position for the first bright fringe. Or not the first, it is the general for all. And as you will put the value of n, then you will get the brightness, bright fringes, respective bright fringes at this position. Clear? So overall it was all about the diffraction and the central maxima. This year in your syllabus only the what is the diffraction of light, that definition you have to prepare, you have to understand, learn this definition. I have explained as means many ways I can explain. I have done, I have shown all of this. Then the diffraction of a light at a single slit, that I have explained how it is working. The light source, then a slit over there, and I said the difference between the slit and the aperture. Slit is a vertical cut, a very thin vertical cut through which the light can pass it. It is called the slit. This is the slit, and this is the aperture. This is the aperture when a hole is there. So it is, we are taking the slit, and through this all the light when passing through it, and as per the property of the diffraction, the light bends through the edges, so you are not getting in front of that only this much portion brighter, even just above that this much portion also you are getting both the side brighter. This portion the light is coming and bending till here, so this bright white portion is the bright fringe you are getting, which is called the central maxima or central fringe over there, which I have shown in this figure also. This is the central maxima, means the diffraction is over there and the entire portion is the bright, and after that you are getting first dark at this point, both the side. So from here you are started getting the dark and bright fringes like this way. And this is the distance between the slit and the screen is capital D. The distance between the length of the slit is small a, and this is the center where from these two sources the fringes or waves are reaching in the same place. So bright patch over there, and due to the diffraction this brightness spreads between this point and this point. The entire is the central bright fringe, and the path difference from M to P and N to P, that is the lambda, is this much portion extra, which extra portion we had calculated nk and we had supposed that is the lambda. If it is the lambda, so a sin theta is equal to lambda, and from that we got the position of this point, which is theta equals to lambda by a. And at this position you are getting the first dark. So that is why it is written over there. The position of the first dark is lambda by A. Similarly, the position of the second, that will be 2 lambda by A. Then position of for the third, that will be 3 lambda by A. And I explained also between these two, all these secondary wavelets are reaching over there in the opposite phase. Why? Because I said this is the midpoint. If the for the entire slit the path difference is lambda, as I have shown in this, for the entire slit the path difference is lambda. So for the midpoint it will be lambda by 2. Similarly, for the respective point, I will take this and this, then this and this, then next and next. So all they will reach over there in the opposite phase. As you know that when they are reaching in the opposite phase, the ultimately the resultant is 0. So you will get the dark. So they are neutralizing each other. So here there is no effect of the darkness. From there, when they completely reaching over there with the path difference lambda, then you will get a dark patch. So from here it is starting dark patch. So first we have seen the width of the brightness. To calculate that, we had calculated y. As you can see from the position of the P from O, this distance we had taken y. So from both sides y and y, it will be 2y. So 2y is equals to 2y we had calculated, that is equal to the twice of this 2 lambda d upon A, which is called the width of the central maxima. Central maxima width is this much. The entire portion is the central maxima. This much portion, it is the bright fringe you are getting. It is the central maxima, and after that the dark fringes you will get. So we had only calculated for the bright fringe A sin theta is equal, this is the general formula, and when you will put the value of n 1 2 3 like that, you will get the first bright, second bright, like this. And the position or the width, if you want to calculate, so it is the position of this, means the distance of y for the next bright, then second bright, like this it will increase, and just double of that you will get the width. With not with here the second or third, fourth, you should know only the position or the distance from the center. That is sufficient for this. So you have to prepare this much only. So it is all about the diffraction, which I explained all that. You go through it all, and I hope you can understand. Thank you.